Good morning, ladies and gentlemen. Today we are on lesson 13 of module 2, and we are on page 87. We're going to continue with subtracting fractions and this idea of borrowing or regrouping. But before we get started, we're going to write our steps next door. Remember, our goal is to know these steps in our own words. So our steps are, first, we set up our problems vertically. Second, we find common denominators. And we do not multiply to find them. We do not multiply, we always find the LCM. And a lot of times we're getting to a point where some of them we see, because we see that this big one works as the LCM, the larger denominator, but sometimes we actually have to list them out. But it's always the LCM, we're never multiplying. Step 3 is, then we're ready to add or subtract. And remember, we do the fractions first because we always start on the right side. And what we started last night is you may have to borrow. Just like regular subtraction, we don't always borrow. Sometimes we have to borrow. And then we're going to fix those greater than 1 fractions, or what sometimes people refer to as improper. So we're going to fix the greater than 1 fractions, and then if we can, we're going to simplify. And remember, simplify means that we're not changing the value of the fraction, we're just putting it in the smallest numbers possible. And the way we do that is we divide both the numerator and the denominator by the greatest common, I wrote that wrong, greatest common factor, sorry ladies and gentlemen. The greatest common factor. So the largest number that fits into both of them is a greatest common factor. Okay, so always have our steps. And again, our goal is to be able to know those 5 steps in our own words. Okay, so I'm over here on page 87. And now I have my steps to refer to. So I'm going to set up my problem as 13 and 9/14 take away 5 and 2/7. And I almost put add, it's subtraction. Okay, so a couple reminders is, notice my fractions are lined up, my 1s are lined up, and my 10s are lined up. Okay, so that's how I'm gonna set it up. And again, my fractions together, the numerator and the denominator, should be the same size as a whole number. Okay, so I did step 1. Step 2 is, I look at my denominators and they're not the same. So what is the least common multiple? And a lot of times it's going to be the larger one. So is 14 a multiple of 7? It is. So it's going to be 14. So I'm going to set it up with 14 as my new denominator. Okay, and what are my new numerators then? What are my new numerators for step 2? Well, what happened to the top denominator 14 to turn into a 14? Nothing, it was just multiplied by 1. So 9 times 1 is 1. What happened to the bottom denominator of 7 to turn into 14? Times 2, so I'm gonna get 4. Okay, so now we are ready to go on to step 3. So add or subtract. 9 take away 4 is 5/14. 3 take away 5 I can't do, so I could borrow. 13 take away 5 is 8. So that was step 3. Step 4 is it's not improper. And then step 5 is there a number that fits into both of these, a factor that I could divide by? And there isn't, because the only numbers that fit into 5 are 1 and 5. And the numbers that fit into this are 1, 14, 2, 7. So that is my only answer. Okay, let's look at number 2. Number 2, I'm going to do step 1. Oops, I'm making a lot of mistakes today. 7 and 3/5, sorry. Take away 2 and 11/15. Okay, so step 1. Step 2 is what could be my common denominator? And again, a lot of times the smaller one is also has the multiple of the larger one. So 15 is a multiple of 15, and 15 is also a multiple of 5. So I'm going to use the larger one. And a lot of times that will be the case. So I set up my problem, and what are my new numerators? 5 times what is 15? 3. So 3 times 3 is 9. 15 times what is 15? 1. So 11 times 1 is 11. Okay. My next one is I have 7. I'm ready to do step 3. 9 take away 11. That is not possible. I cannot do that. I can't do 9 take away 11. So what would I do instead? Well, I'm going to take away a whole, which leaves me with how many wholes? 6 wholes. And I'm going to turn that into 15 fifteenths. But I already had 9 fifteenths. So this is the tricky part. This equals the 7 right here. But I already had these 9 fifteenths. So what I really end up with is 6 and 24 fifteenths. Take away 2, let me scoot that over so you can see that, 2 and 11 fifteenths. So the 7 was changed to 6 and 15 fifteenths, but because we already had the 9, we had to add them. So now I can continue my problem, and I get 24 take away 11 is possible, and that is 13. 6 take away 2 is 4. And then I ask myself, for step 4, is this improper or greater than 1? It's not. And then I ask myself, could I simplify it, which I cannot? So that is my answer. So again, today we're doing the borrowing a little bit more challenging. So I'm going to show you down here, maybe like I'm going to take this and kind of simplify it a little bit shorter of a way, but we're going to continue that idea of borrowing. So on my next problem, I'm going to do the same thing. 9 and 7 18ths, take away 6 and 5 ninths. Okay, so step 1 is done. Step 2 is, what is my denominator? And again, a lot of times it's going to be the larger one. So is 18 a multiple of 18? Yes. Is 18 a multiple of 9? Yes, because 9 times 2. So I'm going to use 18. And what do I get? How did 18 turn into 18? Times 1, which means 7 times 1 is 7. How did 9 turn into 18? Times 2. So 5 times 2 is 10. Okay, so now we're ready for step 3. 7 take away 10 is not possible. It's not possible. So I'm going to take that 1 away, which leaves me with 8 wholes. And what did I do with those 8 wholes? I cut them up into, and I'm going to put it over here, 18 over 18 pieces. So how many pieces did I really end up with? Well, if I cut the whole into 18 over 18 pieces, and I already had 7, well, 7 plus 18 is 25 pieces that are an 18th big. And that's what I would end up with. So again, I kind of set it up a little different here. I didn't rewrite the whole thing. I just showed that the 1 whole taken away turned into that, and then I added them. So kind of 2 different methods, but they both show my thinking. They both show my thinking out loud, so you could see it. What I don't want is not to be able to see your thinking. I want to see where the 1 was taken away and turned into a whole. And then I want to see that you understand that we had to add the new pieces to the original pieces. So again, both methods are kind of different, but both showing thinking. So what do I now have? 25 take away 10 is 15 18ths, and 8 take away 6 is 2. So that gives me my answer. For step 4, this is not improper, so I don't need to fix it. For step 5, I actually can do step 5. There is a greatest common factor. There is a number that fits into both of these. that I can divide them both by. I'm going to rewrite it over here because I ran out of space. But I know a number that fits into 15 and 18, and it is 3. So if I divide those both by 3, I get 2 wholes, and 15 divided by 3 is 5. 18 divided by 3 is 6. So those are equivalent fractions. This is good. This is better. So this would be a better way to show it, but they're both equivalent or both the same. Okay, ladies and gentlemen, have a good evening. Good night.